Happy Wednesday, everybody. I just wanted to show you the agenda really quick before I got into today's lesson. So, first things first, you are going to watch the Edpuzzle on types of chemical reactions notes. You're going to fill in your notes on the notes that I have given to you in that Edpuzzle, answer the questions in the Edpuzzle, and then when you finish with that, you're going to fill out your exit ticket for the day and then fill in your feedback journal. Once you've completed the notes portion of the day, you're going to work on your types of chemical reactions pre-lab. This is another Edpuzzle video that I actually made last year for the lab we're going to do in class tomorrow. It kind of goes through the basic procedures. You're going to pick up a pre-lab packet from the basket or the lab packet from the basket. That way you can read through the procedures as you watch the Edpuzzle video and answer the pre-lab questions ahead of time. Those pre-lab questions and the Edpuzzle video for the pre-lab are going to be due before class tomorrow. Looking at our due dates over here, we've got your types of chemical reaction Edpuzzle note video. That's going to be the name of it. That's going to be due at the end of the hour, and you should be filling in your note sheet with that as well. Once you finish that, you've obviously got your exit ticket and journal. Then we've got our pre-lab Edpuzzle that is going to be due tomorrow at the start of class, and your types of chemical reactions POGIL that you got after your quiz on Tuesday will also be due in the basket tomorrow. If you have downtime in class today and you finish it, you can turn it into the basket today. There is a What's Good Wednesday question on Classroom, so you can go ahead and answer that if you want to as well. But I'm going to get straight into our chemical reaction notes. All right, so types of chemical reactions. Your learning target for this set of notes is I can differentiate between the types of chemical reactions. The first reaction we have is called the combination reaction. The general equation for this is A plus B becomes AB, or thing 1 plus thing 2 becomes thing 1 and 2 combined together. Our reactants for combination reactions are going to be two elements or two compounds. One of the compounds should be molecular. The probable products in a combination reaction, you should have a single compound as your product. So one thing at the end of the arrow. And here's an example of a combination reaction. So we've got 2 magnesium plus oxygen gas becomes magnesium oxide. So we've got one thing being added to the other and becoming two things smushed together at the end. So combination, kind of like combos, the snack. Our next type of reaction is a decomposition reaction. So our general equation for decomp is going to be two things squished together that get broken apart. So we've got AB becomes A plus B. Our reactants, we're going to have a compound with two elements. That's called a binary compound. So when there's just two capital letters, that's binary. Or we're going to have a compound that has a polyatomic ion. If it's a polyatomic ion, it's going to be more than two letters up here. So that's a good way to tell the difference. Our products, we're going to have two elements if it is binary. So it's just going to break down into the two elements that made it up. Or we're going to have two or more elements. We might have an element plus a polyatomic compound. So those are our probable products for a decomposition reaction. An example of a decomposition reaction, we've got mercury oxide, and that breaks up into mercury, the liquid, and oxygen, the gas. Solid is an S, L is liquid, G is gas, and the other letter that you should be aware of, or the other letters that you should be aware of, is AQ, and AQ stands for aqueous. All right, single replacement reaction. Single replacement, so one thing is going to be replaced in these types of reactions. Our general equation, we've got A plus BC becomes AB plus C, so one thing is switched out. Our reactants, this is usually going to be a single element in a compound. One element is going to replace the other in the compound, and that compound is usually going to be an aqueous solution. And the element that is replaced is usually less active, so it's going to be usually less electronegative and less active when it comes to reactions. I like to think of these like a third wheel date. So we've got a single person that goes on a third wheel date. After the date, we've got a new couple and a new single person. So a very interesting love triangle. That's how I look at single replacement. The person who is the single is replaced and becomes a couple. So kind of a fun way to remember it, especially with Valentine's Day coming up. Our products, we're going to have a different single, so new single. So in this instance, we have A as the single, and after the date, we've got C as the single, and a new couple or a new compound. So kind of an easy way to remember that one. This is an example. So I've got sodium plus hydrochloric acid. After those guys combine, we get sodium chloride and hydrogen. So as you can see here, sodium replaced the hydrogen. So sodium was single, hydrogen was with chlorine, sodium replaced hydrogen, and now hydrogen's by itself. And I've got a little drawing here just to kind of show you exactly what happened. You might want to add that to your notes as well, just so that's in there. All right, our next, or our fifth type of chemical reaction is a double replacement reaction. So I've got AB plus CD becomes AD and CB. So as you can see here, A and C just swapped places, or swapped partners, or you could say B and D swapped partners. So kind of a good way to look at that one. Something to note about double replacement reactions, these are always going to be ionic compounds. So ions are going to have the charges. I've added the charges in here just so that you can visually see how this works. So our cation is what's going to stay, and our anion is going to flip-flop. So here our cation is positive A over here. Our anion was negative B, and over here we've got negative D. So we've just switched our anions around. That's how these generally work. Our reactants, we're going to have two ionic compounds. Remember, ionic compounds are a metal plus a non-metal, and they are going to exchange cations, or they're going to exchange their front guy or their anions, their back guy. Probable products, we're going to have two new ionic compounds. Something to note, and you're going to need to know this for our lab tomorrow. Double replacement reactions always are going to form either a precipitate, they're going to give off a gas, or they're going to give off water as a byproduct. So these are the three things you're going to look for in a lab setting to figure out if you have a double replacement reaction. A precipitate is when there's not a solid to begin with, but after you mix things, you get a random solid settling in the end of a liquid. Gas, obviously, you're going to see bubbles, and H2O, we can give off water vapor or literally just straight up water. Our probable products, not our probable products. I like to think of this as like a double date. So in the beginning, A is dating B, C is dating D. After the date, A is now leaving with D, and C is now leaving with B. So they swapped partners. Right. Example of a double replacement reaction. We've got barium chloride and potassium carbonate. So barium chloride is going to be aqueous. That means it's just going to be dissolved in water. So it's going to be like a liquid solution, but it's dissolved in water. Potassium carbonate also dissolved in water, so aqueous. That's what that means. And what we're going to have happen here is chlorine and carbonate are going to switch who they're partnered up with. So now I have potassium partnered up with chlorine, where originally it was partnered with carbonate. And now barium is partnered with carbonate, where originally it was partnered with chlorine. We've got an aqueous solution and a solid that forms. And this solid, this barium carbonate, is actually going to be our precipitate. So I have that marked down here just so you can kind of start to visually understand what precipitate might look like in a balanced chemical equation. Our last type of reaction is called a combustion reaction. In my opinion, these are the easiest ones to identify. So the way that you're going to identify these is you're going to look at the products. And if your products are carbon dioxide and water, that usually means you're working with a combustion reaction. When most people think of combustion, they think of something going boom, they think of it giving off fire or something like that. But the true definition of a combustion reaction is that it's giving off carbon dioxide and water as byproducts. Anything in life that is a combustion reaction, such as gasoline burning, gasoline gives off carbon dioxide and it actually gives off water vapor, giving that fire or that exhaust type look that we see out of cars. It's actually a combination of carbon dioxide and water vapor coming out of cars. So like I said, our general equation, we're going to have a certain number of carbon, a certain number of hydrogen combining with oxygen gas, and we're giving off carbon dioxide and water. Our reactants, we're always going to have oxygen, and we're going to have some sort of carbon and hydrogen combination or compound. Sometimes that compound also can include oxygen with it. So you might see CH and O in this compound versus just C and H. So sometimes we see an O in there as well. Our products are always going to be carbon dioxide and water. And an example is methane gas. So methane gas being burned, we've got methane gas, oxygen. This triangle indicates that heat is being added to this equation or this reaction. So we've got heat being added to the equation, and that gives off carbon dioxide and water. At this point, make sure you've added anything you need to your notes. You're going to complete your exit slip on Classroom. So I'm going to go back to our little agenda slide for the day. You've now completed your reaction video notes. Now you're going to complete your exit ticket and journal. And then once you finish those, you've got a pre-lab ed puzzle to work on. So after you've finished your exit ticket, go grab your pre-lab packet or your lab packet, and then work on that ed puzzle pre-lab video. It's only 10 minutes long, and it demos everything that you're going to need to know for tomorrow's lab. And then as a reminder, your types of chemical reaction POGIL is due tomorrow. Your ed puzzle pre-lab is also due tomorrow before the start of class. I will see everybody tomorrow.